Great. Thank you all so much for being here and for joining me. I'm so glad to be here today with this meeting of Our Lady's Rome. Let me just make sure I can see where the chat is in case anyone needs to say, "Hey, we can't hear you or see you," or anything like that. Thank you so much for joining me today. I am really excited to be here to talk to you about MLOps with Vetiver. So this is less a experience for coding along and more kind of an introduction. So I would say probably not a super high priority to install packages and work along with me, but instead I'll point you to resources where you can learn more afterwards. So let's see, am I in the right place? Yes. So I am so happy to be here. So I you can see here where to find me on GitHub or Mastodon or YouTube or my website. I am currently a software engineer at Posit, which is formerly our studio. But like Frederica said, thank you so much for that very kind introduction. Before I worked on open source software full time, I was a data scientist. I have a background in the quantitative sciences, and one thing that really is a link for my career, I feel like a theme in my career, is being interested in people's very practical, real world tasks, and how can we think about systems to make those easier, more effective, more straightforward, guide people to best practices. And so that's one of the reasons I'm really excited to be working on MLOps tools now. When I first came to our studio, I worked on the Tidy Models project for model development, and now I'm working on these tools for model deployment and maintenance. So as we get started, I wanted to maybe find a little bit about like who you are so that I can kind of know maybe what kind of things to talk about or mention. So I think most of the time when I talk to, people in our meetups, people kind of fall into one of these categories. And so I'm wondering if in the chat you can share a little bit about maybe how you see your main professional identity, maybe like what kind of title you have or what it is that you do. So if you can go ahead and type in the chat, like who you are in this kind of sense, that would be very helpful. Great. Thank you so much for doing this. So this is great. We've got some of all of these, I think. We've got someone who's kind of like an ops type role, kind of more in that engineering role, people who are analysts, people who are data scientists, and people who are statisticians, people who are researchers still. So this is really helpful. Thank you so much for sharing that. And this is actually typical, I think, when you talk to people who use R. People have a variety of kinds of roles, and this plays into a lot of what I'm going to talk about, like how do we view our own skill set and what is important for us to be developing in our skills. So here is a big thesis of the kind of work that I'm doing right now. If you develop a model, and by that, what I mean is you train the model, you choose what kind of model to use, you maybe do hyperparameter tuning, like you do something to create a model, then you can operationalize that model. You can be the one to take that model off your laptop where it needs to go to make it reliable and integrated into the rest of an org's operation. The other thing I want to say here is that if you develop a model, if you are the one who creates and trains a model, you likely, in many cases, you likely should operationalize that model. You should be the one to do that if that is what needs to be done here. So when you hear the phrase MLOps, maybe you have some idea of what that means. Maybe you have questions about what that means. And so part of what I want to talk about here is what does it mean to have a machine learning model and to operationalize it? What does it mean? In what cases do you want to do that? What kind of tasks are part of it? And what kind of tools can you use to do that? So to do this, we're going to use a little data set as I walk through this. It's a data set about housing in Seattle, the city in the US. And if you look at what we have here, we've got a price here. And so that's the price of the home, the price of the house, and then some characteristics of that house. So this is in US dollars. So we say what price was the house sold for, given how many bedrooms it has, how many bathrooms it has, how big it is. Like, so that's the square footage of the house. The equivalent in Europe would be like the square meters, right? The square meters of the house, the year the house was built, and then we have a date on here. So this date is when was that house sold. So maybe we have information like this, and then we want to build a model to predict the price with the other characteristics. Maybe not the date. Maybe we do or don't keep that date in. So here, what we've done is we have created a model where we predict the price of the house based on like how big it is, how many bedrooms it has, and how the year that's built. So think to your own domain, right? Like what kind of models do you build when you take some kind of input and you want to predict something, and then you want to you want to make predictions with that model in moving forward. So what do we do with this? Like right now, let's say I've done this, and I've done this on my laptop, or I've done this, maybe I work in some server environment for my organization. But I've done this on like one computer. What does it mean to take this model and to make it useful to other people in my organization? What does it mean to take that model and take it so that the predictions can be used by other systems in my organization? Those are the kinds of tasks that are involved in MLOps. So if we think about what have we heard about MLOps? What do we know about MLOps? It can honestly be kind of overwhelming. So like is MLOps this? Like this is a this is a guide that was put together about the landscape for machine learning and artificial intelligence. And like, do we need to understand all these things on here, all these tools, all these platforms, all these like ways of doing things? Do we have to understand all of them in order to understand what MLOps is? It can be overwhelming out there when people talk about this and talk about various tools that they use. And this is an area where I think there is hype, like hype about what and vocabulary that can be confusing. So what I want to say is give you a definition that we're going to work from about what MLOps is. So MLOps is a set of practices to deploy and maintain machine learning models in production reliably and efficiently. So we're going to walk through how you can approach this and what it means to be able to do this. So some of you are data analysts. And I imagine a lot of what you do in your job is you have there's data in databases or some systems in your org. You are in charge of like generating reports, maybe building dashboards. For you, MLOps is probably a skill you can develop that helps your career grow more. Maybe you can get a different title or a different salary. If you are a data scientist right now, I bet there's discussion around who in your org, who develops models, who deploys models, like who is in charge of it. And like I said at the beginning, I want to encourage you to think about, if you develop models, you are someone, you can, and you are probably the right person to be the one to take the model the last mile into the infrastructure where it needs to be in production. If you are someone who's currently a like a grad student or a postdoc or a researcher, developing the skill to be able to deploy a model that you build is something that can, like for a data analyst, is something that can increase your career potential. If you are not only someone who can build train, fit a model, but you have the skill to be able to take that model to the infrastructure where it needs to be deployed. Like that's a game changer in terms of you having career growth. So this is what I'm going to say MLOps is. So here is a visual way for us to look at this. So let's think about this cycle as as like a model life cycle. So we start at the top, we collect data. Maybe this is in a database, maybe this is we get it from an API. Maybe we get data from, maybe it's CSV files, like we have some kind of data that we collect. The first and very important part of what we do next to get in the life cycle of a model is to understand and to clean that data. If you use R, maybe use the tidyverse for this kind of exploratory data analysis. If you, maybe you like to use data table for this. There's also tools in Python for this, like you may use pandas or NumPy for this kind of like exploratory data analysis. Once you understand your data, the next stage in a model's life cycle is to train and evaluate that model. Again, there's great tools for this. There are, I've worked on the Tidy Models project, and I think it's fantastic. There's so much, like it provides a real nice usability together with like good statistical practices. I love Tidy Models. Maybe you like to use, maybe you're, possibly you use deep learning, like you use PyTorch or Keras, or maybe you build your models, probably not in this group, but maybe at some point you might need to build a model in Python using something like scikit-learn. So over here on this side of this graph, what I want to emphasize is that there are existing excellent open source tools for you to approach those tasks. Once your model is trained, though, like what do you do with it next? How do you deploy it? How do you maintain it in the so that it's reliable and available to other people in your organization? Now, things over here on this other side, I think there's a lot of confusion about what to do, how to do it, and what tools to approach with it. So the first thing I think we have to do is we have to have plans around versioning our model. So we need to, for example, like say it's very common to retrain models on a schedule, or when we know something has gone wrong and so we need to retrain it. How do you keep track of the versions of which models? Just like, why we may end up with challenges around versioning code, we can end up with challenges around versioning models. And we don't want to be, doing model underscore final underscore final to underscore final for real, like we can't correctly or fluently handle this through emailing things around or file names. We need some kind of structure around versioning. We also need some kind of like approach for how to deploy a model. Like how is it that we take the model off of the laptop where it was trained and put it somewhere else so that it is useful in a broader organization? And then once that model is deployed, we need to know how to monitor that model so that it is, we know when something has gone wrong. So these tasks over here are the tasks that Vetiver handles. So Vetiver handles versioning, deploying, and monitoring. So here's how you get started. So if you remember a couple slides ago, I had a model that I called housing workflow. It was a fitted Tidy Models workflow. And the first thing I do is I create a Vetiver model. So when I create a Vetiver model, think of this as a deployable model object. We're when we train a model, we have a lot of information about it. Like in this case, it's a certain kind of random forest. I'm predicting a numeric value. It's a regression model. I know how many features I used. I know all this when I train the model. And so a Vetiver deployable model object allows us to capture the information that we need in when the model is going to be in production in a reliable and standardized kind of way. So the first step for getting started with MLOps is to capture everything that a model needs to be able to go into production, into a new environment. First goal of Vetiver in the way that these model objects are created is to make it easy to do the right thing for that model. So this means, like, what are common failure modes when models are in production? One is that sometimes when new data comes in and something is wrong or different about it compared to the model the data we trained it with, sometimes we can just have silent errors, or like the model will act wrong and we don't know. So instead, we want to make really robust and also friendly to the people maintaining the model ways to check new data. Another big issue that can make models hard to deploy is that we need to have excellent tracking of the dependency of the model. This means things like the version of R, the version of model packages, like what did we use when we trained it? That's what we need to put into the environment where the model is going to be deployed, this like other new computational environment. Making it easy to the right thing also extends to how we report on the model. So we have a template in the package for creating model cards, which are basically a template for creating responsible reporting of what a model is and how it acts. So you can open up the template here, and then you can it has all these sections, and this is kind of like a semi-automated kind of template where there are some things where we can we can automate the reporting, and some things where a human being needs to say what the purpose of the model is and whatnot. All right, so let's walk through these a little bit more in detail. So first, MLOps is versioning. So MLOps, what this really is about is managing change in models. So when we have models that we retrain, maybe we retrain with new sets of data, or maybe we have some kind of some kind of conditions under which we retrain, we need to be able to manage the change in that model. Second, MLOps is deploying. So what this means for Vetiver, we adopt a kind of like an industry standard that deploying means putting models in REST APIs. REST APIs are not the only ways to deploy models, but it is a good option for kind of the 80% use case, maybe more than that, 90% use case. There's a reason why, like, if you look into how do people put models into production, we are generally standardizing around this idea of putting models in REST APIs. If you're like an academic or a data analyst, you may or may not have worked with APIs a lot. And if you haven't, I think that the best way to think about it is that it's a standardized way for separate computers to talk to each other, for separate computers that are, on different systems. It's a standardized way for you to say, hey, give me X. And then the computer says back, here you go, here you go. It's like an automated way for computers to exchange, an automated standardized way for computers to talk to each other. So in this idea, in the modeling context, what this means is there's some server, some computer that has the model on it, the object that can make predictions, and that computer is available to other computers in, say, your organization and your system. And so, say another server, another service or something, maybe it needs the predicted price, maybe to maybe this is about understanding something in your city, or maybe, maybe it's actually like a housing website, and so the server that, maybe let's say is the website, let's say, there's a new house that has come up. It's of a certain size, a certain age, it has bedrooms and bathrooms, and I need to know the predicted price for this. I go and I make an API call to the server that has the model on it, and I say, here is all the information about this house, and the server that has the model on it says, here's the predicted price, and sends it back. So REST APIs are like the industry standard for most deployment use cases. And then MLOps is also monitoring that model, understanding, is that model performing the way that we expect to? So this is about watching the model and understanding, does the performance agree with what I expected from before? So this is about the statistical properties of the model. And models model performance can fall off a cliff without you noticing, unless you are tracking the model performance. Often when we do, software engineering, like we build code, we know when it breaks, because the logs say it's broken, we have errors, right? Computer says no. But with machine learning models, they can fail, and they will just happily keep on going, making predictions that are just absolute nonsense. Machine learning this is one of the things that makes MLOps unique compared to, say, the delivery of software. Like if you're a general software, like generic app kind of software, machine learning models will fail silently and you will not know it. So this is why monitoring is important. So let's walk through how we do this with Vetiver. So in Vetiver, when we version our models, we use pins for this. So right now I am showing how to do this with Posit Connect, which is like a Posit Pro product, but you can also version your model in S3 buckets, in Azure's infrastructure on Google Cloud platform, the Google Cloud Storage's platform, or if you have some situation where it's literally a server, like on a shared drive or something, you can version there as well. So the idea is, like, where are you going to keep your models? Like, where does your organization want to organize the models? Here are all the models we know about. Here's their metadata. Where are you going to put this? This is often called a model registry. So you can use some kind of backend as your model registry, and no matter what it is, S3 buckets, Connect, anything like that, the code to do this is the same. So we see the same code here. I'm going to show you what this looks like for an example on Connect here. So here is where the binary object is kept. And you can see there's metadata here. We know we can use, the hashing to understand which version we have. We have metadata like, what is it called? What's the description? And this is all automatically generated. We don't need to, the name right here, that's the only thing that's not automatically generated. The rest of this is read off of it. And notice that it is an RDS file. This is a binary object that can be used to make predictions. Whoops. All right, so that is versioning our model. The next thing we want to do is we want to create a REST API. So we can do this, in R, we do this with Plumber. And so we start and we set up a REST API for this model with one line of code, this Vetiver API. What this will give you, if you run it on your laptop or your computer locally, this will give you a local version that you can use to make sure things work the way you expect, and for local debugging. I'll show you what it will look like when you do that. It's here. I am gonna actually put this in here in case you want to interact with this yourself. So this is, let me make it a little bigger. This is automatically generated interactive model documentation, model API documentation. So it does things here like it will, oh, I should have woken it up. It will tell you exactly where the pin is, that it exactly which version of the model object are we using here. And then the main endpoint that we have is this predict endpoint. So we can interactively work with this. Let's say we have a 3-bedroom, 2.5 bath, like 1,800 square foot house that was built in the year 2000, and we can say try, and it will show us what the predicted output will be here. And we can come in here and do, let's say, like, oh, what if it had one more bedroom, like we can try and see, and it will give us predicted prices for both of them. It also tells us how do we interact with this model, like via curl. So this is a way for you as a model developer to be a good collaborator with the people who need to interact with your model. These are people like software engineers, SREs, web developers. This is like a contract between you, the person who developed the model, and the person who needs to use the output of the model. And this all works automatically, right? Like we've made it straightforward for you as the model developer to be the one to get the model over the last over kind of that last mile, like over that last little bit to where it needs to be worked with. So there we go. So that's what the REST API looks like. But where does it work? How does this happen? So the Vetiver works on Posit's Pro products like Connect. And so when I showed you this right here, this is deployed on Connect. But this is open source software. It doesn't only work on Pro products. It works on basically any server where you can take a Docker container. So, and that's basically anywhere. So this means you can go to any of the cloud providers, whatever infrastructure your organization has. You as the model developer can say, here is the Docker image, here it is. Notice the difference in verbs here. So on Connect, you literally use one function to deploy, and it is literally deployed on Connect. For the Docker case, what the function does is it prepares all the artifacts you need, and then you use Docker commands like docker build to build that container, and then you can push that to whatever registry your org uses for Docker containers and whatnot. When I first started getting exposed to Docker, it felt like what is this? This seems kind of outside of my wheelhouse. So what we want to do is, for the person who has more experience with like stats, machine learning, model development, we want to give you the tools to be able to get familiar with something like Docker, to be able to do a good job of generating Docker files that are as small as possible, as fast as possible, and use good design principles so that you can be a good collaborator and a good partner when it comes to the model lifecycle. Oh yeah, so this is the same. Okay, great. All right, so your model is deployed. You took your Docker image, you pushed it to Azure's cloud, Azure's registry, and then your org was able to serve that Docker container maybe in a scalable way that you need. How do you know the model's doing what it's supposed to be doing? You do that by monitoring your model. So there are functions inside of Vetiver to help you efficiently do that. So you can compute metrics over some aggregation period, and then we can pin those back and forth. You decide how you want to handle when there are overlapping dates, and then we have results here. So let's say we are here, we're going to use a validation set. set that is, say, like the most recent dates. Like let's imagine these are new houses that come in, and we had to serve a prediction, and then maybe we found out their real price after they sold. So I can compute from the predicted price and the real price on my validation set, how good of a job did we do? So we have here, we see some sort of standard metrics for regression models, RMSE, R squared, mean absolute error, and we can keep track of those over time. And then we can make tables, we can like explore this data, we can visualize this data. So this right here shows we can, since it's data, right? So it's like using standardized data formats, we can operate it in ways that we're familiar with and end up making something that looks how we expect. So let's look at this example here. So this is an example dashboard. An example monitoring dashboard. It shows here on the main site, how are the metrics doing? We have mean absolute error in the price, RMSE in the price here. We can see, does it go up or down? How is it acting? This is what we create with this dashboard. It's like it's another template, and it shows you how would I go about making a plot that people should be able to see, like every time we monitor in the model. And then it also gives us a place to show people what does the visual documentation for the model actually look like. So we have functions and then templates for getting started with model monitoring. So I'm getting close here to the end here, but if I'm thinking about why might Vetiver be a good fit for someone like you all, like who is starting to think about operationalizing your model? It is built for people who have not done these kinds of tasks before to get started quickly. It is built in terms of like the documentation, the way the functions are designed for you to be able to get kind of to that first deployment as quickly as possible in a straightforward way. But it also is built to be extensible and to support scaling. So say you're in an org that is at the beginning of their maturity in terms of MLOps. You can use Vetiver to get started, but Vetiver also provides an opportunity for growth. That if you're like, oh, I need to move to a more scalable infrastructure, we have support for making those Docker files, getting that going the way that you need to. So as just a summary, what Vetiver does is it versions your model, deploys your model, and monitors your model, and it works for both R and Python. I know that you here are our users, right? Here we are with Our Ladies Roam, but this package was built to serve the needs of people who choose R or Python, or teams. Like if you are in a team that some people like to use R, some people like to use Python, Vetiver is a good fit for you because it looks the same on the other side. Like if people are interacting with the model, it looks the same, whether that model was trained in R or Python. It gives you the freedom to choose the best approach for the task you are using. So maybe in some cases, you like to use Python, and in some cases, you like to use R. You are free to make the best choice because it provides the same kind of infrastructure for these important MLOps tasks. Here, this is, I'll just, whoops. This is, right. So this is on the Vetiver documentation site here under function parity. And if we scroll down, we can see that we can see that these functions look very similar between R and Python, and we have the ability to move fluently back and forth because the design is pretty consistent. Because it turns out MLOps tasks are very similar, whether you're doing them in R or Python, or maybe next year we all are going to be training Julia models. I don't know, but like the actual tasks are the same conceptually, and so we can write a consistent interface to do it in any way. So as a reminder, MLOps, if you see the word out there and you're like, gosh, what is that? I don't know. MLOps is a set of practices to deploy and maintain your machine learning models in production, so they don't mess up and fail on you, so they're reliable and efficient. And that is what Vetiver sets out to be, as a framework for these kinds of tasks. So if you're sitting here and you're like, well, I'm a postdoc, like how is this useful to me? Why should you, whether you're a data analyst, a data scientist, a statistician, someone in academics, like why should you be interested in MLOps or excited about MLOps? The first thing is that this is a very concrete way for your work to get connected to the rest of your organization. And it allows you to scale your impact in the organization. A data practitioner who can train a model and deploy that model is someone who has really impactful, valuable skills. And so if you are someone that can do that, then your skills, your impact in the organization where you are is scaled up from an if you can't deploy your model. If you have to be like, oh, it's someone else's job to deploy the model, I only develop the model. If you're someone that can do it both, then your impact is greater. So I'm going to pop up some things here for ways to learn more. I'll just like copy some links and share them with you. Actually, I'm just going to share the slides as a whole. That's a better idea. I'm going to share the slides as a whole so that you can come in and see these resources. I especially probably would point you to this webinar that I did with Isabel a couple months ago. There's a whole recording that you can watch about how to get started with Vetiver in your particular case. And then I will just say thank you very much. So I'll leave this up and we can see if there's any questions from folks.
Thank you. Thank you very much. I don't see any questions. Maybe you'd like to ask the question directly. You can unmute yourself and ask the questions.
Yes, Lisa, do you have a question?
Yeah, since no one else went, I'll jump in.
Do it.
First of all, thank you. That was super helpful to see. So I guess I'm sort of wondering if you have recommendations for, I mean, you seem to like Posit Connect would be a dream. Currently, like at the organization I'm at, Docker is not really well known even. So do you have like a suggestion for like I don't really know what to call it, but like a baby place to start? What are the intermediary steps I should take?
Yes. Okay. So I am going to share a URL. So one of the pages that we have on the main Vetiver site is about like getting started with Docker. Like, how do you use Docker really? Like, please walk me through the steps. How do I build it? But at the end, we have this section, what if I don't know how to use Docker? And there's a couple, these are great. I really like the one that, so Noam Ross did one, Docker for the user, and Sean Cross did that first one, Enough Docker to Be Dangerous. And I think those are great. Those are really good. They're all of them are good, but if you're an R user coming to this and you're like, what's up with Docker? I think these are like the best ones to get started with to understand it. So if you it does involve like using the command line, right? But if you are someone who can like use the command line a little bit, you can use Docker. It is like it is not harder than the things you already know how to do. It is just different. It's just different, right? And so these are the resources I recommend for people getting started with Docker, especially from maybe more statsy or R analytics kind of background versus a software engineering background.
Thanks.
Any other thoughts or questions?
I just jump in. It was a very interesting talk. Thank you. I was just wondering because part of your talk was about like understanding if the model is doing the right thing. And I was just, yeah, maybe you explained it and I didn't get it, but I think if you could maybe explain to me a bit, what does that mean and how does that work? Maybe, I mean, I think it's a very broad question, but
yeah. So there's different, so great question. How do we understand what the model is doing? So there's a couple of different ways to like it's broad and there's like sort of different sort of aspects of how to do this. I think like a first basic way to do this is with a like we document the model, right? Like let's just start with here. And so if you are let me find this and pull it up again. So this is this idea of like let's set a framework for just explaining what the model is and how it does. And so there is, I think I have a link.
Yeah, I think it's on your slides.
Yes, let me, no, I'm looking for an example. Let me find it here. I have one of these set up. Shoot, let me find it real fast. So, because that one to explain, like walk through how do you make one, et cetera, et cetera. But I have somewhere a finished one, like that you can kind of see what it is, and you can see how we want to do things like make sure we measure performance, not just of the model overall, but say like disaggregated performance along some axis that's important to the model, maybe in terms of fairness. There's also fairness metrics you can use, and then there's issues around explainability. And so these are kind of I would say like the main suite of things to think about when you're understanding how do I understand that the model is doing what it's supposed to do. First, we document, right? Like write out how did we train it, so people know, right? It's not some like there's no information, like people know how did I train it. What data did I use? What were the distribution? Like let me able to look at all that. That's one sort of aspect, basic documentation. Next level up, or another aspect would be to use fairness metrics to be able to measure, say, do I see differences in performance across groups? And we like there's these very famous failures, right? Of models that maybe if you look overall, it looks fine, but it turns out that there's much higher, say, false positives for one group than another, and then like that's an issue of fairness. Then there's the issue of explainability, which is like for any given prediction, or for the model as a whole, or for the model as maybe an individual like prediction, why is it doing that? You know, if you're using something like a linear model in some way, then it's straightforward, right? But like if you start to use more complex models, like a random forest, like I showed, or one of a whole other set, how do I explain the prediction? So let me put a few resources to learn more about these kinds of issues. So there is we have a part. So this what I'm going to say is about tidy models specifically, but there are similar approaches. If you like to use MLR3 or you like to use Python, there are similar pieces of software to be able to say, like, how can I explain my model? How do I know when I can trust my model? So in terms of deploying the model, these would be like slightly advanced use cases, right? Like right now, you would probably need to because people's issues or needs around explainability tend to be quite custom. They tend to be quite specific to their use case. And so we are working, this is actually one of the things we're working on this quarter is better documentation to show some examples. Like how do we go about incorporating explainability scores into the REST API, and things like that. So those are a couple of questions to this broad, important topic, ways to approach it. And then certainly this is an area that like this is all possible right now, but we want to make it easier so that people have more documentation to look at.
Mm-hmm. Thank you.
Thanks. Great question.
If there is no one else wanted to ask other questions, I have one, if
Great.
possible. So, Julia, thank you very much for your talk. It was very nice, and it was the first time I heard about this tool. So it was really interesting to know more about it, and especially from you, who are the owner of this tool. So my question was related. You mentioned the notion of fairness, right? But fairness can be dependent on the model you are using, dependent on the context, and sometimes it's even very hard to define a fairness metric. So how does it work? Do you have a pre-specified metric, for example, in supervised models? Or...
Yes. So this is a pretty big area, but let me try to point you to a few intro things. So fairness is usually measured by there's two ways usually. One is usually called group fairness, and that's when you have a whole population that you're giving predictions for, and you look to see, like, do different groups, usually legally protected classes, do they experience the same kinds of error rates or the same kinds of the same kinds of accuracy. Like you look at the like, say for classification, you look at the confusion matrix, like the 4 parts of the confusion matrix, and you understand, do different groups have the same kind of ratios, across the confusion matrix. The other way to look at fairness is called individual fairness, and for that you look to see if people or observations, usually people that are similar, we define by some similarity metric, do they experience the same predictions? So it's kind of 2 different ways of looking at it. The group is much more common. Group fairness is much more common because it's much more straightforward to implement it. I'm just gonna, I mean, I know this is kind of like obvious, but I'm just going to drop a link to just the Wikipedia on it, because it talks about, if you go down to the group fairness criteria, it does the mathematical definitions of like how we often look at it. I'm going to point you to a paper. Let me find it. That looks at some by it. So there's a good paper about how some metrics are bias transforming metrics and some bias are bias preserving. And so let me share that here. So here's a paper on distinguishing between group metrics, how some they have different basically implications. Like if you were to look at, say, the predictive parity versus the true negative rates, right? Like they have different works there. And the other thing that I like a lot, another paper I like a lot, that is one that distinguishes between two worldviews. And one of the worldviews is what you see is what you get, like WYSIWYG, and one is the we are all equal worldview. And so some of the metrics actually they fall into two categories that you can use them. And then the last thing that I'll share with you is this fairness tree that walks through so the tree, so it walks through, if you scroll down on that and you look at the fairness tree, it kind of walks you through different ways of measuring fairness and which ones are appropriate in your use case. So it's some great information on there about that.
Yeah, that's very nice.
Thank you
I
very
love
much.
the tree.
Yeah, the tree is very helpful, I feel like.
Yeah. So I know, because I was working in reinforcement learning, and there the notion of fairness is it's not well defined. So it's very hard.
Well, so there's a lot of definition. There's actually a lot of great definitions, but which one is right? Which one is right for the particular use case you're in? So I think
I was wondering, do you have also, so are you able also to define a user fairness metric?
That one's a little more difficult. So let me find a resource for that about how to do. So the ones that I shared are all about group fairness, but
they're all implemented.
Yes. There are some sort of proof of concept implementations for individual fairness. And let me find you. There's a really nice paper that's just, and it kind of outlines the difficulty, because it is difficult because you have to have a similarity metric that you measure to be able to use that. Okay, let me find the paper so I can share with you the paper on it's like a proof of concept, and it's an open research area. I would say it's an open research area on what the it's like how to best do individual level fairness. So this is a good paper that kind of outlines a current proof of concept of how to do that.
Thank you. Okay, are there any other questions? Okay, if there's no other questions, I'd like to thank you, Julia, for helping us understanding how we can share our best model with others in the team. So, and then, so make sure that the version will stay as is, and then so have the chance for a framework that it's consistent and stable to for sharing our model validation. Okay, I think time is up for some reasons, so we are allowed to use this link, but it's limited as well. And I look forward to see you for the next event. And in the meantime, I thanks Julia very much, because it's really an honor. I met you at the conference, and you know, it's always nice to see you. She's got a nice YouTube channel with many interesting videos that are very useful for you to understand the modeling and how to. There is many things that you can find there. You do modeling, in the meantime you tidy data and learn many things that you maybe do not expect to learn. So to thank you very much for all for coming. I need to close the time. If you like to take part to any of our future events, please get in touch. If you like to be a co-organizer, please get in touch. What else? Sorry about what happened at the beginning of this at the beginning, but you know, it's all learning. Thank you very much for all for coming, and I hope to see you again soon. Yeah.
Thank you so
Thank
much.
you, Julia. Yeah. Thank you, everyone.